Right. Good evening, everyone. Good and welcome, everybody. That was our day. How many of us joined the communion service virtually? Please confirm you can all hear me, everyone. Okay. Good evening, Deborah. Nice to hear, and that your day was fine. Hi. Okay. Blossoming evening. That's new. Thank you, Adepeju. Good evening. Oh, Agatha, I also joined late, so don't worry. We're in the same boat. Better late than never. All right, so I think we're good to go. We have quite a number of us on the call already, so we can get started. All right, so can we all see my screen? Can we confirm that we can see my screen? Okay, all right. Thank you very much. Oh, Deborah, thank you. I am actually. My day was not as stressful as Tuesday, so yeah, I think I look a bit more relaxed. Thank you very much. All right, so let's get started for today. Today we're going to be looking into introduction to serverless computing. And yesterday was a very interesting class. Kudos to our facilitator, Mr. Moses, so doing a very good job yesterday. So to prove that he did a very good job, please can you remind me of what he taught us yesterday? What was our topic yesterday? Hope we're not going to go and do expo. This one I'm not yet seeing chats. Auto scaling. Oh, nice. So Deborah, if you get 50% mark, and for Isola will get 100% mark because it's auto scaling and ELB thoughts. Yeah, so auto scaling and load balancing. Thank you. Yes, so that's to show that it was really entering. I'm happy to hear that. I'm happy to hear that. Please give me a minute. Let me mute my notification. Okay, I think I've done that. All right, so thank you for remembering what you learned yesterday. It's something that gladdens our hearts to know that we're not just talking, right? That it's actually entering. So today we're looking at another interesting concept, and today I'll also try to. I know on Monday we had somebody said she was hypoglycemic or something that she needed sugar because it was a lot on Monday. So today I'm going to try and also kind of go back to what we did on Monday and address it in a way that would understand, especially for the instance types that's caused a bit of confusion for us. So those are things we're going to be looking into this evening. All right, without further ado, let's get started. So again, I said we are going to be looking at introduction to serverless computing, right? But before we talk about serverless, it means that there's server, right? And we've been talking about server basically from the beginning of this week. We said the AWS server service is easy to write, so we've been discussing it. But then again, for the sake of maybe people that did not attend that class or something, we're going to be starting this evening's class talking about what server is, getting a general grasp of it, right, and making it as relatable as possible to us. All right, so let's get in. So, like I said, we're going to first be looking at what is server, right? Yes, Evelyn, we have started. Oh, can you hear me? Evelyn, please confirm you can hear me. Oh. Okay, all right. I want to believe everybody can hear me. Okay, all right. Thank you very much, Sephora. Okay, so what is a server, right? Like I said, for us to understand serverless, we have to understand serverful, right? So what is a server? I think we've said it from beginning that a server is like your computer that is designed to process requests to deliver data to other computer or clients, like they are called, that's a technical term for them, right? Clients. So your clients can be anything, can be your laptop, can be your phone, it can be your the one we used to have in our house, the full desktop, CPU, everything, right? It can be any of those can be the client, right? So it's this, or the process of this server, right? um processing or yes, processing requests, delivering requests via the internet or the network is computing. So the server is what handles those processes. The server is what handle computing processes, right? And again, servers can host websites, they can host databases, they can host a lot of things. They can host and handle different processes. And how does it work, right? A user will send a request to the server. So the request can be like, I think I can put in a bracket here, right? Like you're visiting a website now. Then the server will receive that request. Your request can be like going to Google to go and type what is EBA in English, right? That is your request. Now, something carries that request, right, through the internet to where the server is. The server has a database of information sitting on it, right? So it's going to go and go through a store and then look for what the meaning of EBA is in English from its record, and then send that your reply, your response back to you. So you don't see all those processes, right? You just send and then you receive, basically. But that's what is going on. So the user will send the request, the server will receive it to process it, and then it will send back the your response, right? Whether it is the web page or the answer to your question, or it was a file you requested for, whatever it might be. Now, what are the components of a server, right? I know these are some of the things that we did then when we were in secondary school, but let's go a bit high up, right? So, components of a server is the central processing unit, that's the CPU, which is like they taught us to in secondary school, is the brain of the computer, right? It's the brain of the server. It is responsible for processing information and performing tasks, right? So, is the one that is receiving your request, basically is one in charge of receiving the request, processing it. Now the RAM is another component of the server, and what the RAM does is that it temporarily holds data that the server would need to access quickly. I think like I mentioned yesterday, right? It's or was it on Monday or some days last week, I can't remember exactly right now. Like your phone, when you buy a phone, it comes with an internal memory, and then you can also buy a memory card to add to it. So that internal memory, that the internal memory of of your phone can, in quotes, be called a RAM, right? Don't worry, I did an illustration that will help us understand better in the next slide. So we have the RAM, we have the storage disk. Now the storage disk is like your memory card, right? It's for storing data for a longer period of time. So the RAM is for temporary holding of data, right? While the storage disk is for a much more longer period of time. One of the things to also note is that for a RAM, especially for EC2 instance in AWS, if you should stop a an instance, for example, we said you can stop an instance, you can reboot it, you can terminate it, right? If you stop an instance, remember I said when you stop it, you stop being charged, your AWS stop charging you for that instance. But the storage disk that is going to be attached to that instance is usually a separate entity, right? Is a part of the instance, but is not when we're talking about instance type on Monday, right? We said the instance type is the the CPU and the RAM and the network. Basically, that's what the instance type or controls or contains, right? So the storage, which is the disk storage, right, is a part of the server, but it's like an external part of it. You can detach it, you can attach it, just like you can detach your memory card and attach your memory card, right? So the last one is the network interface. So remember I said in this slide that the client, right, you can send a request from your phone to the server. So what carries your request to the server is the network interface. That is what is allowing these two to connect. That's what is allowing these two to be able to connect. Without that network interface, whatever you are sending here will not be able to reach this person. And if it's trying to send it, even if it reach and then maybe something happened, network was disconnected along the way, it will not be able to send a response back to the client. So that's what the network interface does. Now let's look at an example or a relatable example of what a server is. So a server can be likened to a restaurant kitchen, right? The kitchen itself is the server. The kitchen itself is the server, right? Now within that restaurant, you have the client. So just like that image I showed us before, you have your customers that want to order food. So every customer is a client, right? Giving their request. If you see this guy here on this side, you see that he's holding customer order. So he has collected the order of these people, he's taking it to the kitchen. So the chefs inside the kitchen are your CPU. They are the one that is going to go and process what this waiter is bringing. We're going to know what's the waiter. If you've listened to the explanation from the previous slide, I'm sure you can guess what a waiter would represent, and you can already even see it here in my slide, right? So the chairs are the CPU, they are the processing unit, right? And then the storage racks that are inside the kitchen, like your cabinets. When you're in the kitchen, you have cabinets that you use to store your Maggi, things that when you're cooking, you want to quickly be able to grab as you are preparing food, right? That's like your RAM. Like I said, they hold temporary data, right? So that's like your RAM. Then the fridge or your pantry. Your pantry is like your store, not the kitchen now. The store. The store is where you store more food. You store like your backup, so to say, right? That's where you take from. You take from the pantry to the cabinet, isn't it? So you store your rice, you store your yam, you store your meat, all of those things, either in the fridge or in the pantry. So your fridge or pantry is like your disk storage, right? Then the waiters, that's the wait staff, they are like your network interface. So the flow of information, right, is going to be the client, the customer, would send their request through the waiter. So the waiter is what? The network interface. The waiter will collect that request from the customer, carry it to the kitchen, right? Now, in the kitchen, remember the kitchen is a server, right? In the kitchen, you have the chef. In the kitchen, you have the storage rack. In the kitchen, you have the pantry. Or rather, in the restaurant, you have the pantry, right? Now, I was explaining earlier that the disk storage is not usually attached. So most times you don't find your store or your pantry. Fancy word is pantry for store, right? You don't find it inside the kitchen most of the time. It's usually separated, maybe divided by a block or something, but it's not inside the kitchen itself, right? So you find your pantry there. Now, the more chefs you have, the more computing power you have, right? The more the number of chefs that you have in the kitchen. And what does that mean? It means that if, for example, in this picture now, we have how many customers? One, two, three, four. 5, 6, 7, 8, 9, 10, 11, 12, 13, right? We have 13 customers who are sending requests to the kitchen. Now, the more chefs are here preparing or attending to the request of these people, the faster their operation would be. That's the way CPU is. For the cloud, it is called vCPU, right? That's virtual CPU basically. The more chefs here, the faster the process will be. So the same thing in the cloud, you say, or for a server, you say, the more the CPU or the more powerful the CPU, right, the faster the process. Also, the bigger the cabinet that is here, the more space that they have in the cabinet, right? This storage that is here in the cabinet, the more they have, the more they'll be able to store things that they can quickly grab. Say, for example, if you're in a kitchen, right? You have four chairs in that kitchen, and then you have just one cabinet. What will happen? The cabinet will only be able to contain what it can contain. You'll not be able to put so much things there, but you can increase the RAM and add more cabinets to it. The cabinet will still be holding your things like your Maggi, your spice, your what are the things that will put in the kitchen cabinet, your Bonvita, your milk, those things, those basic things, right? So the more that rack that you have, the more RAM, memory, the more data, temporary data that it can contain, right? So now the fridge or the pantry, the bigger the fridge or the pantry, right, the more permanent data it can contain. Hope we get it so far. Do we understand so far? Can we move on? Do we all understand? Okay. All right. Thank you very much. So please take note of two things that I have said, right? The more the chefs that are here, the more the computing power. So now let's move on. How does it all work together? I already explained it, but let's just read through, right? So the customer places their order, that is, they send their request, right? The wait staff, which is the network interface, they will deliver that order to the kitchen. Then inside the kitchen, that is inside the server, the kitchen is your server. Inside the kitchen, the chef or the CPU, they will do what? They will use the ingredients that they are going to pick from the RAM, from the storage rack. Remember, we said the RAM is our storage rack or our cabinet, right? So the chef will pick ingredients from the storage rack that they would need to be able to prepare that request that was sent in. So for computer, in computer terms, right, the CPU is going to pick data or whatever it needs from the RAM to be able to reply to your request that you have sent to it, right? Maybe by asking what is the English word for eba, right? It's to go and search from the RAM and get that information and give it to you as quickly as possible. Now, if that ingredient is not available in the RAM, what will now happen? The chef has to go to the store to go and look, to go and bring it. The chef will do what? Have to go to the store to go and get that information. So maybe you wanted to quickly cook a fried egg. You already put Maggi and salt in the RAM, but you did not realize that, oh, they did not put what else do they use for egg again? For people that use Korea and thyme, right? They did not put Korea and thyme in the storage rack that is inside the kitchen. What will happen? The chef has to quickly go to the store, right, or the pantry, and pick the curry from there and then put it inside the RAM so that next time he needs it, he can easily just quickly pick it from there. So once the chef is done, right, he will give that request or the food that he has prepared back to the waiter, and then the waiter will carry it to the customer that requested for it. Hope we are getting it so far. So yeah, I said just like a kitchen has different tools and areas to handle various parts of meal preparation, a server also has different components, your CPU, your RAM, your storage, that will handle different part of data processing. And If the kitchen has more chefs, right, more food can be prepared at the same time. The more powerful or the multiple CPUs that you have, the more task the computer will be able to do at the same time. Just like in the case of these people, right? If this chef brings this tables order now to the kitchen, because they have how many chefs? One, two, three, four, five, six, right? They also have assistant chefs also in the kitchen, isn't it? This request will be faster. Unlike if it was just one chef that was here, before these people will get their food. I don't know how many of us has gone to restaurants where you order food and in 45 minutes, I have been to a restaurant like that. In 45 minutes, your food is not ready. And it was just rice you ordered for. If you go and check their kitchen, you will find out that it's most likely that they are very short staffed. It's only one chef that is there that is preparing everybody's order. So the more the CPU, right, you have, the more you'll be able to handle more tasks at the same time. So if the kitchen also has more storage rack, the chefs can work more efficiently without going back to the fridge, right, or going back to the pantry. And just like the server with more RAM can access data faster without slowing down to receive it or to retrieve it from the disk storage. Hope we get it, right? Okay, so I noticed that we've not shown you a picture of what a database or a server room looks like. So this is what a server room looks like, right? A server is different computers. Like a server room will contain different servers. So each of these that is here now, one, two, three, four, five, is they are all CPU, computing power units, right? With storage, with everything, servers. So these all servers are usually stored in racks, right? So you put them in racks. So this rack now is one storage server rack. Then they have another server rack like that. It's a server room is usually huge. Now, this is what a data center is like. A data center is basically a housing center for servers. So people like AWS, right, Azure, or companies like that, what they do is they will buy a very large space, and if you enter, you just be seeing these arrays of servers, so you don't need to buy it for yourself, basically. So that's what the cloud is doing. And then don't be deceived by these fronts. This is what the back looks like. Connections, different wire connections. So let's link what we've just discussed now, right? Using the restaurants and the old computing power thing to relate back to what we did last week on Monday. We are talking about instance type and instance family. So instance type, remember I said they are like your chef. We were using the restaurant example, right? But for us to be able to truly understand what instance type and instance family is, right? It's you can use cars. So an instance type is like different category of cars, right? Now, in every car, which is like your instance is like is your server, right? In the cloud. In every car, there is the engine, there is the room for people to sit down, there is the boot, right? So let's say the room that is here where people can sit down is like your RAM, right? And the boot is like your disk storage, isn't it? Now, different categories of car. In this side, for those that knows car, this is a sedan. Sedan are like your small cars, right? Your portable looking cars, right? Those are what they call sedans. So sedans now they offer balance. They have space, right? They have the engine that is good, and then they also have boots, right? It's balance. Nothing is too much. Nothing is looking too much in them. They have a balance of everything. Now for SUVs, these are SUVs. Your Jeeps are SUVs, right? Now SUVs, they have what? More storage space, right? They have more room for people to sit down. They have more room for what are they calling it? In the boots for you to put something, right? And then you now have trucks. Now trucks are what? Are much more bigger. They might not have so much space for you to sit down, but they have more space for you to go and put things like to store. Like their own boots is what is bigger. Now Instance type are like categories of cars, while instance family are like different car models. Now, under sedan type of cars, right, there are different type. You can have your Toyota Camry, just like last week we are talking about how instance types, general purpose is what, T3. So you can have your Toyota Camry, you can have your Honda Accord. They are all still what, sedan, but they are different family. And what's the difference? Maybe Toyota people, they've added a bit of finesse in their own car. It is still a balance. They still have the same balance of storage, of space, of the engine, but they've added something to their own. Maybe for every sedan now, right? Maybe for every sedan car, it's supposed to take about 2 to 4 people, right? So a Toyota Camry can have space for just 2 people to sit down. A Honda Accord can have maybe space for just 3 people to sit down. Hope we are getting it so far. Now, for the types of instance types that we have for EC2, I said general purpose, right? General purpose are like your sedan cars. Say they are compact, right? They are affordable, they are fuel efficient, they are good for your everyday task. The same thing with general purpose instance type, like your T3, your T2, your M5, right? What they do is they provide a balance of your computing, your memory, your networking. If we are using the case of a restaurant, right, as an example, it will mean that these general purpose instances, they have a balance of chefs, they have a balance of the storage rack, they have a balance of wait staff, right? Your waiters that are attending or receiving requests and bringing the request to the chef, right? They have a balance of it. It's not a case that the chef is more than the the storage rack, or the storage rack is more than the number of chef. It's like having one chef in a kitchen, and then there's about 25 cabinets inside that kitchen for only one chef, right? Now, that is what a general purpose instance is. It provides that balance of everything. Then the compute optimize. When you hear something compute, right? Compute means it requires more processing power. And we have said that what CPU is our processing power, is the brain behind it. So your compute optimized instance can be compared to a sports car. They are designed for what? For high speed. They don't have as much storage space, right? If you've seen a sports car before, people that buy it, they are probably most times they are two-door cars, right? Where but they have that speed. They are the type that you see them going on the road and then they just go, they have passed you, right? They are very lovely to have when it comes to speed. But again, like I said, yeah, they don't have much room for what, for extra passenger or for extra load. They have boot though. It's not like they don't have boots, but the boot is not as much as what you have here. So there is more chef. If we are using the restaurants now, there is more chef in that those type of instances, right, than storage cabinet. There is more chef than storage cabinet. Hope we are getting it so far. The third one we talked about was the memory optimized. Now we said memory is our RAM, right? Our RAM. So the example for memory is what, a minivan, like your SUVs. You'll find out that the difference between this car and this one is quite a lot in terms of memory, in terms of space that people can sit down, right? It has more room for people to sit. Just like your memory optimized instances, what happens is that they might have just two chefs, and then they'll have 15 storage racks, right? Maybe what they need, the ingredient they need for their day-to-day running, they need to be able to, retrieve fast, without having to go to the pantry every time, right? So they will need more room, more cabinets inside the kitchen. They might not increase the number of chefs, it might just be just that two chefs. So maybe two chefs to 15 storage cabinets, right? Or four chefs to 30 storage cabinets, that kind of a balance. You know that this one is much more, the person that is using it is much more interested in the storage cabinet, in the memory, in the RAM, than in the compute power. In that kind of a situation, right, it is more suited for when they don't have fast or requests that they need to process, fast. Because what will happen if, in a case of a restaurant, you have 20 customers waiting, and you have just two, what are they calling it now, two chefs. No matter the amount of storage space or cabinets that you have, right, it will not still be as fast as if you have five chefs. But this kind of a memory optimized instance, I can compare it to like all this booker, like mama put. Maybe not your amala, because amala people, they used to have plenty crowd, right? They used to have a lot of orders. But like those people that used to say rice and beans, those that you just see on the road, that one customer, two customer at a time, three customer at a time. So they don't really need that high computing power. They don't need so much chef, but they need where they'll be able to quickly, I need this thing, they will pick it. I need this thing, they will pick it. So they need more RAM. Now, storage optimized is like your cargo truck. Basically, storage. They are much more concerned about storage. They need where they can be able to store their data, not temporary things like your storage cabinets, right? A much more permanent one. So this one has a bigger pantry, so that no matter what is missing in this RAM, you can always go and get it in the pantry. So that is what a storage optimized is like. Is can be compared to a cargo truck, where you have enough space. And this type of instances are optimized for applications that require fast storage, like databases, like they require high storage space, right? Like your databases, like your data analytics workload. And you need to get access to large amount of data. Then this is the kind of instance that you will choose. The last one I'm going to talk about, right, is accelerated computing instance. So this is like your compute optimized, but a higher version. If you notice, what we compared the compute optimized to was a sports car. Now, this is a race car. It's similar to a sports car, but this one has been much more optimized for racing. Now, for you to race, you don't need any storage. You don't need so much storage. In short, it's close to zero storage is what you need. You are much more interested in how fast the car is going to go. You're much more interested in the computing power of that instance, right? Not necessarily storage, because you're not going to be doing a lot of storage work with that computer or with that instance, right? So you need something like this. If you people that watch Formula E and all those racing games, right? You know that their cars are not built for, let us be putting load inside. No, nothing concern them. In short, some of them, you find out there is only one space that is inside for just the driver alone. So that is what an accelerated computing instance is like, right? So what determines the choice, whether it is an accelerated computing instance or a memory optimized or storage optimized or general purpose? What determines the type of instance you are going to select or you are going to pitch to your customer that, okay, use this one? It's going to be dependent on the type of application or the type of workload that they want to put on that instance, right? Say if I own a restaurant and my target is that I'm going to be having customers, 50, 60 customers. I'm not going to go for um I'm not going to go for a a a what do you call it now? A general purpose, right? I'm going to go for something that has, or sorry, rather, I'm going to be going for a general purpose. Why? So that it can give me a balance of the compute, the storage, the memory, right? Because if I'm going to be having 50 to 60 customers at the same time, what would that mean? I need to hire a lot of um chef. I need to have a lot of storage cabinets in my restaurant, so that in case they need to pick something, they can easily access it, right? And I also need to have a big pantry. So those are what general purpose. I will need a balance. But if for me, what I need is just it's only five customers that I'll be needing, right? I would probably just hire just one chef, right? One CPU, one vCPU, right? And then I can have like five storage cabinets for the chef so that he can have access to whatever I need at that moment. I hope we all get it till this point. Hope Monday's class has been hope Monday's class has been hope you understand Monday's class now. Okay. All right. Okay. All right. Thank you very much. Happy. Okay, so let's get back to our business for today. Right. So our business for today, sorry, my mouse decided to stop moving. So what are the challenges of managing server, right? We've been talking about server, right? What are the challenges? Number one is maintenance. For you to be able to maintain the running of, remember what I showed you, the picture of what a server room looks like. Having to maintain each of those server, having to know when this one needs to be updated, when this one needs to, you need to patch this one, if this one has problem, having to go and look for the one that have problem and to fix it is a challenge. Capacity, if too many people are on it, there's issue. You probably have to now go and start looking for how to add more, or you have to shut down one part so that one can start working. Just like our system, you might be running some applications and then they've taken all the power of your system, and then you find out that your system is now lagging. You probably have to go and start closing some applications so that it can speed up a bit. Also is cost. Once you buy a server room, it does not concern anybody whether you are using it fully or you are not using it. The same thing for EC2, right? EC2 is the cloud server for AWS, right? If I purchase a server now, I've thought about it that, oh, these things that I want to put on the server is going to be very huge. People are going to be using it. So I purchased a server of um maybe 8 vCPU and 32 gig RAM, right? Because I had the mindset that people are going to be using it a lot. And when my application came out, people did not really like it, right? It's not like people are not are not coming to use it. So I cannot stop the instance because people are still coming to use it, but they are not as much as I would have wanted it. What will happen? That will not concern AWS, right? You keep paying for the size of server that you have chosen that you want to use, because what you are doing is you are taking that space in their data center, so you keep paying for it until you probably stop that server or terminate that server and get a smaller one, right? Whether you are utilizing your server to the fullest or not is none of AWS concern. That is easy to those are one of the challenges. And of course, scaling. For us now, for AWS EC2, right? Like Mr. Moses taught us yesterday, there's the option of what? Enabling auto scaling. There's that option to say, okay, I've already set it in place that whenever this thing has grown to maybe 80% utilization, add more EC2 instance. Or whenever we're not using it so much, reduce it. Don't add more, just reduce it to like just two, or leave only one to be running, right? There is that for EC2. But as we are going to find out in serverless, there's no need to have to go and enable auto scaling for serverless. It does that by itself. And we're going to find out, or we're going to learn about it now. So, serverless computing. What is serverless computing? Basically, it's saying you don't need servers, right? Now, what does this mean? It means that AWS is one that is going to manage everything. Remember that for your EC2 instance, right? AWS is managing, or they are in charge of the data center where your physical server is going to be sitting. But you have to be updating that server, right? Because you have chosen remember your instance type is you're going to select your operating system on it, whether it is Windows or Linux. It is your duty to go and be checking whether there's a need for that operating system to be updated. Just like if you are using your system, right? It is your duty to update your system, to update the software that is on it, to patch it and all of those things. It is your work. AWS will not come and do it for you, right? Even though it is a server, they are just taking care of the physical one. They are not in charge of updating for you. They are not in charge of patching for you. That one is your own work and your own responsibility. But for serverless, AWS is the one that is going to be doing the patching for you. In short, you're not going to be seeing the server. You're not going to know that you're even using a server. You will not even know what type of server that AWS is choosing for you, right? In the back end, on AWS end, whatever it is you're putting is still going to be on a server, but it will not concern you. AWS will be managing it full-fledged. It is called serverless because even though the servers exist, you don't have to deal with them directly. Now, in serverless, what happens is that you write your code. You've developed an application, you write the code, and then you just tell AWS, help me to run this code. Whether they now decide that that code is general purpose instance that it will need, or is compute optimized, your own is, I need this thing to run, it is going to run. Whatever it is that they put at the back end does not concern you. You also don't need to think about scaling. You don't need to think about server maintenance at all. What are the characteristics of serverless computing? Number one is what? Hostless. Again, you are not hosting it on any server. You are not, for you on your end, you are not seeing anything. You are not going to go and select instance type. You're not going to go and select storage. You're not going to go and select any of those things. So it is hostless. Elastic, in the sense that what? It can expand or decrease depending on your need. It can expand or decrease depending on your need. There's an analogy in front that we're going to use to explain these things, right? Later in the slides. It can expand or decrease depending on your need per time, without you having to go and enable auto scaling. Auto scaling is part of his birthright. You don't have to go and enable it. Is what it is his job. It's part of his job, basically. Right? It is stateless. When you say something is stateless, it means it's not storing data. It's not having any storage. It does not need any storage. So unlike server where you need to have storage to keep your data so that the processing unit can pick it, this one does not need, right? It does not need at all. We are going to explain it later. Number four is that what? It is event driven. What does it mean to be event driven? A serverless computing means it is triggered by an event. It is something that said, okay, maybe um you wanted to log in now to a system. You have inputted your username and password, right? That's action that you've done. Immediately you click the button login. That event of pressing the button login will go and trigger the code that that person has uploaded to say, this person has pressed login. Oh, what happens when this person press login? It will go and check, and then it will do whatever it's supposed to do for that person. Also, one of the characteristics is what? It is also like a Lego block. For those of us that know a Lego block, those things that we used to play with as children, right? That you build. I think some of us still play with it as adults, right? And you need to build. And how does it relate to a serverless? It's different small code functions that can you can put together to make what? A bigger application, or to make a bigger thing. So it's little that forms a bigger one. Separate, independent little littles that form a bigger one, right? It is highly available. Unlike EC2 instance that you have to select which availability zone you are going to put it. If you put it in only one availability zone, it's going to stay in one availability zone. If you put it in two availability zones, to be in two availability zones. Unlike that, Lambda would automatically be in all the availability zone that is possible. So there's nothing like, oh, something happened to this availability zone, so my code is no longer running. Automatically it moves to the next one. It will utilize the next availability zone. Then it is, your costing is based on how you use it. It's based on, let's assume that you have set up a serverless computing for clicking on that login button. It is only when somebody clicks on that login button that activates a action, right? That is when you'll be charged. If nobody clicks on login button, you will not be charged. Unlike you have the full application on a server, whether somebody come and click on login or not, you are paying for your server. Do we understand it to that point? Boss, you're saying something. I didn't get. Please, ma, your. Okay. All right. So we get it so far. All right. Thank you. Let's move on. Yes, Chidozie, you don't need a physical server of your own. In short, the whole essence of cloud computing is that you don't need a physical server of your own. But even in the cloud, there's server and there's serverless. EC2 is server. It's just that the server is in the cloud. You are still going to manage the server. You are not just buying it physically in your compound. You're not importing anything and putting inside your office space, right? The physical one is in AWS, but you're still going to be in charge of managing, updating it. That's for the EC2. And then there's serverless. Serverless is you're not in charge of doing anything. You are not seeing it physically. You are not going to be maintaining anything, basically. All right, so what's the comparison between a traditional server and serverless, basically? So first, looking at this picture here, this is like their model operandi, right? For a traditional server, when you send the request, all of these things are on top of what a server. If you send a request from here, it's going to go through maybe that login button. The login button will now go to the back end, and then now go through security, and then now go and pick the information that you need from the database and come back like that. All of these things are on one server. They are inside one thing. But for serverless, they can be separate. You can have an event that says, like your login now, right? When you click on that login will only go have, it only has business with what, with the security arm. It does not have business with database yet, right? So it's going to go and check security. Does this person have the correct credential to be able to log in? If yes, it will allow you to go in. So that is what that function, the event, is doing. Remember we said serverless is event driven. That is what that event is doing. So its only concern is what, is security. After you have logged in, you have now clicked on, maybe you wanted to buy something, you've now clicked on the good that you want to buy, right? So that one needs to go and get the details of that goods that you click on that website. Where will he get the details? In the database. That event, clicking on that goods, is an event, right? It will go to the database. It does not have any business going to security again. It will come here. So unlike traditional server that all of them are in the same place, all of these ones for serverless can be in different entity. Just in your code, you will just write that when somebody click on login, this is where it has business with. This is the service that it has business with. When somebody click on a picture of a good, it's going to go to the database and collect the information of that good and bring it back to the person. Now, also, what are also the differences, right? Apart from the mode of operation, is that one, for a traditional server, you will pay for the server even when it is idle. I already explained that. For serverless, you will only pay when your code is running. Only when your code is running is when you are going to be charged. If your code is not running, you will not be charged. For traditional server, you will handle scaling manually by yourself. You'll be the one to be adding and removing server, except you enable auto scaling, right? Even for that, you have to be the one to go and enable the auto scaling. But for serverless, AWS will automatically scale. Once they see that, maybe for that login now, right? One person logged in is going to just what, it's just one function that is going to run. It's going to just release one lambda function to go and do what, to take care of that person's login. Now imagine that 50 people were trying to log in at the same time. Automatically, what will AWS do? It will expand or enlarge whatever it is that that request is sitting on, to be able to accommodate all that 50 at the same time. And maybe it now goes back, maybe 30 minutes later, it's only two people that were trying to log in. It will reduce it back. So automatically it handles the scaling, whether it's scaling out or it is scaling in. Then for traditional server, you need regular maintenance and updates. Like I said, you have to be the one doing that. for, even if for your EC2 instance, you have to be the one updating it, downloading updates, updating your software, patching it, and all of those things. But for this one, you don't even know the server. You don't even know the type of instance or whatever it is that AWS has is running your function on, right? So it does not concern you. AWS will be doing their updating, they'll be doing their maintenance by themselves. Now, for traditional server, right, it takes longer to deploy, while for a serverless, it is fast. Why? Because it's just running your code. For traditional, before you deploy an app, what will happen? You have to first of all go and select instance type. As short as the minutes we use in setting up instance, right, is as short as it is. For some people, it's long, especially because you have to first go and think, okay, this application I want to deploy now, what kind of instance will fit it? Is it compute optimized? Is it memory optimized? You have to go and think of all those things. But for serverless, you only put your code. AWS will decide which of the instance type is best for it and run it by themselves. Hope we are getting it. Now, what is AWS Lambda? AWS Lambda is basically AWS serverless computing service. So just like the EC2 is AWS serverful computing service, right? AWS Lambda is the serverless computing service. So it's the serverless version of EC2 instance. And what it is that it is where you run your code without worrying about servers. It will run your code in response to events. Now, those events can be somebody uploaded a file, right? It can be a button, like the button of login that you clicked on, depending on what you have set it to do, depending on what you have written in your code, right? It's going to run your code in response to whatever event. In AWS Lambda terms, it is called triggers, right? So whatever triggers that code is what the code will respond to. If you have said, for example, when the guests come, right, serve the food. That was the your code. In the code you wrote down for your people in the house. When the guests come, serve the food. Now, the guest coming is what? Is the event that is going to trigger the food being served. If the guest does not come, the food will not be what? Will not be served. It's as simple as that. Now, AWS Lambda supports our very common languages for those that code, right? Such as Node.js, Python, Java, Ruby, etc. Right? So many coding languages is supported by AWS Lambda. Also, I said here that you can also think of it like a vending machine. When you push a button, what will it happen? It will deliver a snack to you. So, for the snack to be delivered to you, the event of pressing a button has to happen. You don't have to worry about what the vending machine is sitting on, or what is controlling the bringing of the whatever it is you have pressed. But once you press, if you press one, if one is tied to Coke will fall, basically. Hope we are getting it so far. Hope I'm not too fast. Someone said my screen is blurry. Hope it's not network. Is it still blurry? Still blurry. Ah, that's interesting. Oh, that's not my network. Okay, those that are saying it's tiny, are you using a phone? It's clear. Okay. It's sharp. Okay, now I'm confused. Is it sharp or is it blurry? Because I think as much as possible for this slide, I try to make the wordings big. Okay, it's clear. All right. Maybe for those using a smaller screen, maybe that's why um it's happening. Maybe that's why it's happening. Maybe you're using a phone. Maybe that's why it's looking um small or blurry from your end. Also, it can be your network on your end. If it's clear on some people's end, it might be your network actually. But then we'll all get the slides. So maybe just try and follow along with what I'm saying. We'll all get the slides. It will be uploaded to our LMS. And also, please, the slides for Monday's class has been updated to include the examples of explaining the instance type. So we can all go back and check that slide again in case you've read it before. Okay, so what are the basic components of AWS Lambda? The components of AWS Lambda, number one is the function. The function is basically the code that you will write for a specific task. The code that you write. So the code that you're writing is um, if login button is pressed, security check the person's credential. If the credential is correct, allow the person to log in. If the credential is not correct, bounce the person. That's the code you have written, right? Now, the second component of AWS Lambda is what? Is an event. Now, in the explanation I just gave now, the example I just gave now, the event there is what? If the login button is what? Is clicked. That's the event. It is that event that will trigger this function to what? To run. It is the event that will trigger the function to run. And again, I said your event can be just file upload. It can be an API request. It can be one application saying, please, I need this data from you. It can be that event. It can be any event actually. Then the execution role. So remember we talked about I am role some I think last week, right? We talked about I would say I am roles are temporary permissions that you give to services to be able to communicate to other service. So you also need to give Lambda an I am role depending on where you want it to go. Say for example, if you have said if somebody uploads um image into the S3 bucket, right? Lambda, once that person uploads the image to S3 bucket, what you are going to do is that you are going to take that image and you are going to send it either to the database or you are going to send it to the backend that is going to work on the image, whatever it is that is the task that you have given onto it, right? Now, for Lambda to be able to take pictures from S3, it will need a permission, a role that says S3 allow Lambda to take things from you, basically. So without an execution role, Lambda might not be able to communicate to where you want it to communicate to. So those three things are components of Lambda: the function, the event, and the role, the I am permission role that is going to allow Lambda to be able to access the services you want it to access or to talk to get what you want done to be done. So I gave her the example here that you should imagine a system that sends you a welcome email whenever someone signs up to a website, right? I don't know if you've signed up to a website before. Maybe you just signed up to that website, and then by the time you check your mail, you've seen, oh, welcome to blah 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 blah. We're glad to have you here. Check out this, check out that, right? That sign up is an event. So you have set it that whenever somebody signs up to this website, Lambda, go and trigger our notification system. The notification system is now going to go and send a mail to that person's email to say welcome. So the event that is going to go and trigger Lambda is what? Signing up. What is Lambda going to go and do? Lambda will go and tell the notification service system that, okay, somebody has signed up, yeah, send email, right? So it's an automatic process once that event triggers it. Now in AWS, this is basically the module operandi, right, for AWS Lambda. You upload your code to AWS. You can write your code in any language that you want. Sorry, please, can you give me 1 minute? I think I forgot to plug in my system and it's showing me that it's going to be low. Please, a minute. Let me just quickly plug in my laptop. a break for the attendance and then we'll conclude once. How many minutes break, Mr. Idiri? Okay. Please let's quickly fill our attendance. 5 minutes. All right. Thank you. Please fill your attendance. So this weekend is going to be the last date. For those that have not been filling your attendance, please fill. If I don't have any record of you or either our class, my class, or Mr. Moses' class, will not be able to create an AWS account for you. Please, and please take this attendance serious. Or you can click on the link that was sent. Ediri sent a link just above your message. Honora, is it no? It's not the developers that send the message. It is automated. So they've written a code down. The developer has written a code down to say do this when this person does this. So that's why it's usually fast. You won't have a developer sitting down permanently on the system waiting for somebody to be signing up, right? So it's automated. They've already written the code down. Then we are going to have question session after. So just note those, write those questions down, and then we'll take them during the question session. Okay, welcome back. Welcome back. Hope we have gone and peace and drank water and lick sweets, whatever it is we could do, and filled our attendance in this 5 minutes. All right, so can we all still hear me? Please confirm you can still hear me and see my screen. Debbie, you're laughing. All right, thank you very much. Okay, so let's quickly get back into it. Please come back, or if you go and please come back, come back, come back. Break is over. Okay. All right, so let's get back into it. So I was saying that the operation of AWS Lambda, right? The mode of operation is you upload your code to AWS Lambda. You will have written the code somewhere using any language of your choice, right? Then you upload that code to AWS Lambda, or AWS Lambda has a code editor, right? For developers, they'll know what a code editor is. So you can write your code in AWS Lambda code editor too. Then you will set up that code, right, to trigger from other services. So like maybe so sorry, I heard my background noise is quite much. Apologies, please. So you set up the code like a trigger for that code, right? You set it up to say, okay, maybe this thing is going to be triggered by S3, or is going to be triggered by Lambda, or is going to be triggered by a button, whatever the trigger is, right? You need to add that. Then that trigger is what is going to come and trigger your Lambda function whenever you upload it. So Lambda is going to run this your code here whenever it is triggered. Lambda run your code. Again, you upload your code to Lambda. So Lambda stores your code. It have it in mind. You have put a trigger in place. Your trigger can be, okay, when somebody clicks this button, right? That can be your trigger. Now, whenever somebody clicks that button, what Lambda will do is that's your code that you have uploaded to it, it will run it. So whatever it is that is an instruction in that your code that you uploaded to AWS Lambda, that's what Lambda would run. And then you will only pay for the compute time that you use. Compute time meaning the number of minutes that your code will run for. So if your code is running for just 2 minutes, right? Um, remember that instances are usually built, per hour. Your server are built per hour, right? So if your code only runs for 2 minutes, you'll be charged for only 2 minutes. If your code only runs for 5 minutes, you'll be charged for only 5 minutes, basically, right? So when we say event driven architecture, what does that mean, right? It means in general terms, right, that something is an event that is going to trigger these things, this set of actions to happen. It's an event that will trigger a set of actions to happen, basically. So, and your AWS services like your S3, your API gateway are what connects, like if you have an application that wants to connect to something else, right, in AWS, AWS API gateway is going to be like standing in front of it. So your API gateway can be a trigger as well, right? So you can say that, oh, when another application from outside is trying to get to maybe S3 bucket, for example, once it sends a message to the API gateway, the API gateway would trigger Lambda. So Lambda will take that code that you have sent to say, oh, whenever I get this kind of request from the API gateway, it means that the person wants to get to S3. Then it does what you want it to do, basically. So let's use this example. So these are an example of event-driven architecture, right? Some of these logos that you are seeing here, we probably we've not spoken about them, so don't don't fret, right? So these are events, different events, right? Triggering different things. So this is maybe a CSV file. Now this CSV file is being uploaded to an S3 bucket. So the code that probably this person has written is that whenever a file is uploaded to S3 bucket, S3 bucket is going to, oh, sorry, S3 bucket is going to trigger this function, the code that you have uploaded to AWS Lambda. Now, what is in that AWS Lambda is probably that whenever somebody uploads picture to S3 bucket or upload any CSV file to S3 bucket, Lambda go and tell SQS. So SQS is AWS queuing service, right? It's what you call like a message queuing service. So it's others. Let's say for example, I sent a request for um to a database to say I need the information of the number of students that are here, right? And then somebody else also says, oh, I need the number of teachers that are in this school. Now those two requests are going to the same place, right? But what SQS is do is that it's going to collect the all the requests and then line them up and say, okay, this one you are going first, this one you are going first, or you are going second, right? It's like a queuing service basically. So this S3 bucket, this CSV entering into S3 bucket will trigger this Lambda. The code that this Lambda is getting, or the function that it is running, is that whenever a CSV file is inside the S3 bucket, tell the AWS queuing system, let it take it. Now, once the SQS, right, simple queuing service, that's the full meaning. Once it gets this, it will trigger another Lambda function. So this is to tell you that it is not just one. You can have different functions set up for different events. So this S3 bucket is a trigger for this particular function, right? This SQS to this function is a response, right? Is a response of the function that it had that give it to SQS. Now, for this second Lambda function here, this one becomes a trigger. So this one now is going to trigger this function that is here. And this one's code, whatever is in the code, is that now take that file that they put in the S3 bucket that was sent to SQS. Now you take it and put it in AWS Amazon DynamoDB. DynamoDB is a database. So you get the flow of it. This triggers this one. This one runs your code that you have say whenever something enters S3, take it to SQS. It takes it there. Then SQS is also another event that is going to trigger another function. And this one's instruction, right? The instruction that this one has is that take that and take it to DynamoDB, basically. So that is for this one. This other one is somebody else sending a request. Remember, I talked about API. So an application is sitting on a stem and is sending a request via the internet to the API gateway. So the API gateway is like an event trigger. So whatever it is that it has sent, it could be maybe this one is the application is saying, I want to get data, or I want to post, or I want to delete, right? So different events, right? Get is an event, post is an event, delete is an event. So depending on whichever one comes through the API gateway, if the API gateway says, oh, get, what will it do? It's going to get data and then send it back, right? If it says post, it's going to post it. It will go to this particular function here, post it to DynamoDB. If it says delete, it will go and delete whatever it is that this thing has said it should delete. So this one is what is going to trigger. And depending on what it is getting from here, three different events, three different functions, right? Hope we are getting it so far. Of course, the last one is what somebody an event is triggering event bridge. Event bridge is AWS service for managing different events as well, right? So in that event bridge, you have probably put rules to say, oh, when this and this happens, if this and this is in place, do this. That's code. What if that rule is true? Let's say, for example, the login rule, right? Our event is what? Sign in or log in. You have put a rule that for somebody to be able to sign up to this website, the number of their password must contain a capital letter, a small letter, and a number, right? That's the rule they have put. Now, when you put that rule, if somebody signs in and then puts a password that is um capital letter, small letter, and number, right? It has met the condition of this rule. So this rule is going to go and trigger Lambda. So this rule, the meeting of that rule triggers this lambda, and what it will now do is it will now add that person's name to the database. But if the person did not meet the rule of the password, it will not bother to trigger lambda until the person meets the rule of the password, right, before it will trigger lambda. Hope we get this. Can I move on? Do we get this? Do you understand this? Is there any part of it you want me to re-explain? Okay, so which part do you want me to re-explain? Okay, which area do you want me to re-explain? Everything, or there's a part that confused you? I'm seeing gotten. Okay, so those that don't understand, right? Hold on, I'll come back to this picture. There's something in front in the other slide that might explain it much more. So just hold on. If after that illustration you still don't get it, then we'll come back to it. Right? Okay, say everything. Okay, so just hold on. Let's go to the other slide. I'll come back to this particular picture. Let's go to the next slide. Okay. So this is the next slide, right? We're going to be using a taxi service to explain AWS Lambda, right? We're going to be using a taxi service to explain what AWS Lambda is. Now, a taxi service is like a company that has taxis, right? Now, what is the order of events? You request for a ride. You will be the one to do what? To request for a ride. So that is the event. So your event is like you requesting for a ride from a taxi app. You push the button on the app, right? And then the taxi will arrive to take you to your destination. So what takes you to your destination, that taxi itself is what? Is your Lambda function. What brings the taxi to you? What is the thing that makes that taxi come to you is what? Is your pressing the button to say I need a ride. It's like your Uber app. Once you click on order a ride or get a ride or something, right, it is going to go and trigger them to say, oh, somebody has requested for a ride, though, taxi, go and meet that person. So the taxi is what? Is the Lambda function, and it was triggered by the event of you pressing the button on the app to say order a ride, right? So that is the event. Now, when you have, sorry, I keep pressing the next button. When you have requested for the ride, right, you've requested for a taxi, which is the event. The service will dispatch a car to you. Just in the same way, when an event occurs in an AWS Lambda setup, the platform will dispatch a Lambda function. A Lambda function, like I said, is what? Is like your taxi. So the Lambda function is what is going to go and handle that event. Now, if more ride requests comes in, multiple, that's different events, right? Which, going back to this image, like this one, like this one in the center here, right? There were different events. There was a get event, there was a post event, there was a delete event. This one in the middle now is multiple events, right? At the same time, there was a get, there was a post, there was a delete event. Now, if that happens for a taxi ride, if I have ordered a ride, Shegun has ordered a ride, Tayo ordered a ride, all of us ordered a ride, right? What will happen? The taxi service is going to send multiple taxi, which is multiple Lambda functions, right, to go and meet the demand. Are we getting it thus far? When there's multiple events, right, multiple function will be what? Will be released to go and meet each of those requests. So like the image of the get, the post, the delete. There's a function, there's a taxi to go and meet get, there's a taxi to go and meet post, there's a taxi to go and meet delete. Now, handling the different events is the task. So the different functions, just like your different taxi, there are different tasks that they are going to handle. Say, for example, I might have ordered a taxi to go to work, right? Someone else might order it to go to the shopping mall. Someone else might order it to say, take me to the airport. Different events. Just like that post, get, and delete event. So the taxi service is going to release the taxi to go and take somebody to work. It's going to release a taxi to take somebody else to what? To grocery. It's going to take release a taxi to take somebody else to the airport, depending on the function that has been attached to that particular request is what is going to determine the kind of function that will be what that will be triggered. If I have written different lambda function, the first lambda function that I wrote is what? When somebody press the login button, check the security credentials. Does it match? If it's match, okay, allow them to enter. So at the point when somebody presses the login button, the function, the lambda function that is attached to that particular trigger, that is attached to the trigger of login, is going to is going to come, and then it's going to carry out the instruction that was given to it. When the taxi comes, you give it instruction, abi carry me to the market. The taxi is going to carry out that instruction, basically, right? Now, after the person has logged into Jumia, the person has seen the picture of a good that she wants to buy, and then she clicks on that good. Now, in the back end, I've already written a lambda code or a lambda function that says when somebody clicks on a picture, what you should do is go to the database, maybe the DynamoDB or the RDS, right? Go there, go and pick information of this picture that this person click. So it's going to tell it, oh, this is the name of the bag, this is the producer of the bag, this is the color of the bag, this is the price of the bag. All those information were stored in the database, right? But you only get that information if you have clicked on the picture of that product. So that function that is attached to clicking of a picture, the task or the instruction that has been given to it is what? Get the details of this product. Its own function is different from the function of the person that is logging in. So there are two different functions. Do we get it? Is it making sense? So multiple rights, multiple function. Different request, different function. Different things you want, different functions you write, depending on how you want it. So just as multiple people can request ride at the same time, different events can trigger different lambda functions at the same time. At the time when me I'm logging into Jumia, the function that will be attending to me is a function that is attached to logging in, right? That is going to go and check my credentials. At that same time, somebody might have already logged in before and is at the point of clicking picture, while me, I'm at the point of logging in. Somebody else is at the point of clicking picture. The function that will be attending to that other person is the function that is attached to, if somebody clicks a picture, go and get the details of that picture. That is the function that will be attending to the person. While for me that I am just logging in, the function that will be attending to me is the function of login. Now, the last part is what? No event, no taxi. If you are not going anywhere, you are not going to, if you don't press the order a ride button in your app, the taxi service will not send a taxi, right? Similarly, if there is no event, if I'm not trying to log in, the AWS function for logging in will not come and answer me. If I have already logged in and I was just going through all the pictures, I did not click on any picture, the function for go and get the details of picture will not come. It will not be released, it will not run, basically. Do we get it now? Does that help? Does this illustration help now? Okay. Okay. All right. So thank you very much. So let's move on. Oh, glad to know that it's helpful. All right. So thank you. So let's move on. So what are the use cases of Lambda, right? Um, in what areas do they use Lambda? Again, Lambda is not for every um operation, right? It has its own limitations as well. As good as it sounds and as beautiful as it sounds, it has its limitations. I'm going to look into that in the other side, in the other slides, right? But for now, let's look at use cases. Number one, you can use it to do what? For real-time data processing. Maybe you want to automatically resize images when somebody upload them. You already have an application, a code that you have written that says, um when somebody uploads a picture that is 20 gig, the person wants to reduce it or compress it to just 5 gig. My application does that, right? But for my application to be able to resize, what will happen is that anytime somebody uploads an image, that uploading of an image will trigger the Lambda function. That Lambda function will now go and run that code that me I have written, that will do the work of compressing the image, right? The event of me uploading an image is what will serve as a trigger for the Lambda function. Remember, I've already uploaded my application code to Lambda. So Lambda has that code stored somewhere. So whenever you upload an image, what will happen? Lambda will just go and run that code. And the code, the instruction I've written in the code is what? Reduce the size of whatever image is uploaded to 5 gig. And then when you have reduced it, send it back to the user. So Lambda will run that code. The image um would be reduced, and then to give it back to you. So that's one of the use cases. Also is web application backend. Like your backend, like someone has that, oh, she thought that it was a developer that was sending those welcome emails. It's not. At the back end, somebody has written a code to say whenever someone signs up for the first time to our website, send an email. So you signing up, once you click on, you have put your email details in that form, and you click on sign up. That pressing of that sign up button is going to go and trigger the code that person has written, that this person is a first timer. Oh, ring bell, ring bell, ring bell. Welcome the person, send a mail, right? That's a back end work. You are not seeing it. IoT applications, you can use Lambda to process data from different connected devices. So again, because it can handle multiple events at the same time, right? You can write functions for different events. So it can be attending to this one, another function can be attending to this request, another function can be attending to this request, all at the same time. Then you can schedule a task. So you can say for example now, like for us, we're going to be setting up accounts for you, right? You're going to be practicing and doing some experiments. You can spin up an instance. You can start an instance, for example. So because we don't want gbese on our neck, right? Maybe somebody will now go and set up an EC2 instance and forget about it, and it will just be running and be incurring costs for Incubator. What we can do, we can write a Lambda function that will say at 12 p.m., or sorry, at 12 a.m., right? Every day, delete every EC2 instance that was created. We can write that Lambda function. Now, what is the event that is going to trigger that function? 12 a.m. Once the time is 12 a.m., that Lambda function will be triggered. It will wake it up. Oh, yeah. So that's the event that is going to trigger it. And what will happen? It will go and carry out the instruction that I've already written in the code that deletes every EC2 instance. So maybe you set up your EC2 instance today. I mean, I've already written a code. Then tomorrow morning, you now wake up, you now say, what happened? I can't find my instance. It's because something has happened already when you were sleeping, while men slept, right? So you can use Lambda for scheduled task, basically. All right, so what are the pros and the cons of serverless computing? What's the advantage and the disadvantage? Number one advantage is that what? It is cost efficient. And again, you only pay for when the function is running. You only pay for when the code is running, basically. So you're not paying if the code is not running. If the example of the application that I gave, that you started an application, right? And in your mind you felt that kini o ma blow. You expected that 200 people will be trying to sign into your website every time. You'll be having a lot of traffic, right? So if it was server, you'd have probably gotten a server that has a huge capacity that can handle the request that you're imagining in your head. But you now later found out that it's only 5 people that used to come and visit your website. You cannot shut down the website, right? You cannot shut down that server, because the 5 people that are coming are still coming. But then it's no longer, you don't need as much as what you have already, right? And for every time that that server is there, you are paying for it. You're going to be charged for it. So for a serverless computing, it is only when somebody comes to log in, that is when you'll be charged. When anytime that that function, that code is running, that is when you are going to be charged. You are going to pay for the time, the amount of time that that code will run for. Say for example, somebody has clicked on login. In your code, you have said check through the security, check that the person have um all the correct credentials. If the person has correct credentials, let the person come in, right? The number of minutes or seconds it takes for Lambda to run that your code, to check through security and check whether this person has the correct credentials, that's what you're going to be charged for. After he has confirmed and it has seen that the person has it and the person has logged in successfully, you stop being charged for that particular function. Another function can be running for another thing, right? Maybe like when somebody clicks a picture now, that function will run again. You'll be charged for the time that that one will use to run as well. So no need to pay for idle servers. Number two, like I already explained in the beginning, right, is automatic scaling. For EC2, you have to go and enable auto scaling. For Lambda, you don't have to. Whether it is one person that is going to use your application, or is 1 million people, it's going to automatically scale to contain as many requests as is needed at that time. Number three advantage is what? You don't need to manage server. I've already said it. If especially if you're a developer, you will not have any business with infrastructure. Basically, your own is write your code, put it on AWS. AWS would decide on the kind of server that it's going to use to run it. AWS would decide on when to patch it and all of those things. Scaling of it, basically, it's all AWS business. You don't have to worry your own pretty head. Then of course, faster time to market. If you have developed an application now, before you start thinking of when what kind of server you need, before you make that decision, go and meet management, you can just put your code and it's running. Your application is there for everybody to use at a faster time. No need to set up any infrastructure. Now, for every good thing, there for every advantage, there's always a disadvantage, right? So what are the advantages of a serverless? Number one is cold start. And what is cold start? Cold start basically means, for those that are probably cold, you know that if you are running a code for the first time, it will take a longer period because it's going to do what is called initialization, right? So cold start means that if that's the very first time they are triggering that function to work. Maybe that's the very first time since you've written that code, the very first time that somebody is going to click on login, it's going to take a bit of a long time, right? Not so long like 5 minutes, all right? But in computing words, every second counts, every microsecond counts, right? So it's going to take a longer period to run than when it has been used for consistently. When it has been used consistently, it has gotten used to the process. It does not need to initialize again. So either you're using it for the first time, or somebody has logged in January and then nobody logged in again till December. It's been a while. It's going to have that cold start again. It's going to go and initialize again, basically. So those are one of the disadvantage, cold start. Number two is limited control. Again, like I said, AWS is one that is going to determine the kind of infrastructure that your code will be running on. If they see that, oh, this your code, when it is triggered, is going to need 2 vCPU, 8 gig RAM, right? That's what they will set up for you, whether or not you have and it's per the minute that it's running, right? So whether or not that's what you wanted or not, you don't have control. You cannot determine the kind of instance they are going to be running for you whenever your code is running. So you have limited control over the underlying infrastructure. Then execution time. This is very important to note, right? AWS Lambda functions have time limits. It is only good for code that has a maximum execution time of 15 minutes. So if the code you have written is going to take more than 15 minutes to run, Lambda is not good for you. If the code you have written is going to take more than 15 minutes for it to run and to execute all the instructions that is in that code, then Lambda is not for you. It's not for you. It's going to start having issues. So it is best for functions that would have smaller times, lesser than 15 minutes to run, basically. Then, of course, complex debugging. Now, because these things are events driven, so you can have event for login, event for clicking picture, event for kinikon, event for kinikon, event for this. They become what, like I said about their characteristics, right? Is that they are like Lego blocks. So those small, 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 when an issue happens, it becomes quite difficult to begin to troubleshoot and look for where is this problem coming from, because you have to go and start tracing which particular event is causing this particular issue, right? So it is much more challenging to troubleshoot with serverless than it is um with a server setting, with your traditional servers, basically. All right, so I've added links to resources that you can also go and read up on to give you more understanding on this topic. So, question time. Any question? Okay, I'm seeing some questions already. All right. Okay. Question one: does that mean to use serverless computing, you must know how to code? Most of the time, right, is developers that usually make use of serverless computing a lot of the time. Now, um, does that mean that you as a cloud person will not get involved, especially if you're not a coding person? No, you will know how to use Lambda. You don't have business with the code that the person is coding. You don't have any business writing code. The only thing is the person has written the code. Your own is to help the person put it on AWS Lambda and to set up how the whole thing will go. Your business is not, if you're not the developer, right? Your business is not in writing the code. You collect the code from the developer, help the person to put it on AWS Lambda. Shikena, that is it. So you don't necessarily have to know how to code. Can we decide on whether to use server or serverless? Sure, definitely. Depending on what you want to do, right? Say, for example, I already mentioned that the AWS Lambda are not good for tasks that will need to run for more than 15 minutes. If your application will need more than 15 minutes for it to run, then AWS Lambda is not good for you. It's better to go and use the EC2 instance, right? It's better to use EC2 instance. Between the two, which one is more costly? Now, I like that. And I think I did not put it in the pros and cons. Remember, one of the pros or the advantage of Lambda is the fact that it is cost efficient. Now, cost efficient does not always mean that it is cheaper. What do I mean? Again, AWS is the one that is going to decide on the infrastructure, right? Say, for example, now, um, 1,000 people are trying to log in at the same time, right? So it means that it's that same function that all of them are trying to access. So it's going to need to deploy more Lambda functions of that same one. So we talked about scaling, right? So it's going to deploy more. And for you to be able to deploy more, it means it's going to need more underlining instance that is going to be running on, basically. It can decide that it's going to use a expensive instance for you. You will not have a choice, right, than to pay for it, at least for that time that it's going to run. So in some instances it might become more expensive, in some cases it might not. So depending on the scenarios, you can't say, oh, this one is much more costly, this one is. Some people run away from um Lambda because they feel like, oh, if plenty events is now triggering now, AWS will just be spinning off and be spinning off and be spinning off, and then my money is going, right, for the time that it is running. And some believe that that is what is best for them. That is what is much more operationally efficient for what they want to do. So they use that. Is GitHub a cloud computing service? Uh, hmm. It's not a computing service. GitHub is not a computing service, right? Computing service is you are able to put applications on it, right? So GitHub is a I've forgotten the word we call it now. Ah, please remind me. It's a um uh give me 1 minute. I need that word. I need that word actually. I need that word. I yes. I've seen the word I was looking for. It's a version control, right? It's a version control service, basically. So what GitHub does for you is maybe you have written a code, for example, for an application, and then you updated the code. So when you hear version 1 point something, version 1.1, version 2.0, what it means in technical terms, right, is just that a change has been made to that particular code or to that particular service, right? That is what is version 1 or version 2. So that's what GitHub is. It's not necessarily a computing service. It is not. It might be sitting on a computing service, right? It's going to be sitting on a computing service, but is Lambda an I am role? No, it is not an I am role. It is not. An I am role is a permission. Lambda is not a permission. Lambda is not a permission. It is a service. It also needs permission. A Lambda also needs an I am role to be able to access. Say, for example, in that picture that I showed of somebody uploading a CSV file to S3, right? And then Lambda is going to take that picture in the S3 bucket, will trigger Lambda, right? And then Lambda will take that picture and send it to the queuing system, right? AWS Lambda, right, would need an I am role that will allow it to be able to access the S3 that is going to collect file from, and to be able to access the SQS, the queuing service that is going to give a file to. So Lambda is not a role, is not a permission. It is a service. Itself, it needs permission to be able to access other service. Lambda also needs permission to access other service. Any other question? Yeah, repository. Thank you. Thank you very much. Repository is Thank you so much, Jumoke repository. All right, so no further questions, I believe. Well, may I have questions for you? May I have questions? I hope I can go ahead and ask my question. So let's do our knowledge check. We have few minutes. That's just few questions. Are we ready? Can we take our knowledge check now? Our assignments will start coming once we have set up our environment. So please, that's why we need you people to sign up on time. We are going to be sending a quiz this week. Please, that's going to be the final opportunity. Anybody that does not do that quiz and did not do the previous one, at least one of the two, it will not create account for you. So please. So our knowledge check now. Question one. Question one says, which of the following is not a characteristics of a serverless computing? Which of the following is not a characteristics of serverless computing? Number one, no server management is required by the user. It means the user will not be the one managing the server. Number two, automatic scaling based on demand. Automatic scaling based on demand. Number three, you'll be paying for an always on infrastructure. You'll be paying for an always on infrastructure. D is that it is event driven execution model. D is that it follows event driven execution model. So which one is not? Which one is not? See? Are you sure? Final answer. See. Okay. Oh. All right. So let's see. Are we correct? And the answer is C. Yay. All right. Correct. That's the correct answer. So again, you're not paying for any infrastructure that is, because it's not going to be on. You only pay for when the code is running, basically. So this is not a characteristics of serverless computing. Question two. What is the primary benefit of using AWS Lambda in a serverless architecture? What is the primary benefit? A, you pay for the infrastructure even when it is idle. B, you have to manage the underlying server manually. C, you only pay for compute time when your code is running. D, you need to configure and scale the servers yourself. What is the primary benefit? Are you sure it's C again? C. Why? People don't want to choose D or A. Okay, I think we've had enough response. Let's check. Are we correct? C. Yeah. So I did not confuse you people. People did not even pity A. I've chosen C two times. You can choose A or B. All right. So C is the correct answer. In AWS Lambda, you only pay for the time that your code is running. Question three. In the restaurant analogy, what does the CPU in a server represent? In that analogy I gave us of a restaurant, what does that a CPU represent? A, the chefs that are preparing the meal. B, the fridge that is storing ingredients. C, the wait staff delivering the food. D, the tables where the customer sits. Shey because I say people should choose A, you people are not choosing A. Ha! Don't follow my words. You can choose D or C again if C is your friend. Okay, all right. So the answer is A. The answer is A. The chefs that are preparing the meal are like the CPU in a server. They are the one that process. The CPU is the one that process the information, the request, basically. Just like in a restaurant kitchen, it is the chefs that will process the customer's order. So the chefs are the CPU in a server. Question four. In the analogy of AWS Lambda being like a taxi service, in the analogy of AWS Lambda being like a taxi service, what does the event represent? What does the event? So, what is the event in that analogy? A, the driver arriving at your location. B, requesting the taxi to come and pick you up. C, the car waiting for a customer. D, paying for the taxi before the ride starts. What is the event that will trigger? Let me not say anything again. What's the answer? B. Okay. Let me see more answers. B. Okay. All right. So let's check. Are we correct? And the answer is B. Yay. So yes, requesting the taxi is the event. That's the event that will trigger the taxi service company to send a taxi to you, basically. So just like in our Lambda, if the taxi is our Lambda function, once you click on order a ride, right, it will trigger the Lambda function of taxi to come and meet you. So the event is requesting the taxi to come pick you up. That's the event that triggers. All right. Next question. What happens during a cold start in AWS Lambda? What happens during a cold start in AWS Lambda? What happens during a cold start in AWS Lambda? A, the function starts running immediately. B, the function experiences a delay because it has been inactive for some time. C, the function scales automatically based on traffic. D, the function terminates if no events are detected. B. Okay, let's see, because our time is fast spent. And the answer is B. Yes, that is what a cold start basically is. The function will experience a delay. And remember, we said that is part of the cons or the disadvantage of AWS Lambda, right? The cold start. The last question. In an event driven architecture, which of the following triggers the execution of a function? So which of these can be the event that triggers, you know, the execution of a Lambda function? A is a manual, this is like a bonus question. A is manual starting of the server. B is like an event like file upload, API request, or data updates, whatever it is. C is a scheduled system restart. D is a pre-configured CPU usage limit. Which one would trigger? Which one would trigger? B. B. Okay. B. All right. Okay. Let's go and check our answer. All right. The answer is B. So for those of us that got 100, yay. For those that got 90, yay. For those that got 50, for those that did not get anyone, for even attempting it, well done, right? And I don't think there's anybody that did not get anyone, at least from all the answer that I saw. Maybe someone just missed one or two. So you guys are doing well. You're doing very, very, very well. I'm so proud of you guys. Thank you so much for paying attention. Thank you for opening up when you don't understand, because that always makes us go back to say, okay, we need to get you to understand. So thank you very much. Thank you for pushing continuously. We'll all reach our bus stop. All right. Thank you all. See you in the next class on Monday. And please be on the lookout for your weekend quiz. Please do it as quickly as possible so that we can set up our AWS environment and we can start taking assignments from next week. All right. Have a lovely night rest, everyone. Bye. Thank you too. Thank you too. Mwah, mwah. Thank you.